Welcome to this demonstration of Dynamic Risk Register. This is the example that I will be using for the demonstration. It is the reaction section of an ammonia plant. We are feeding nitrogen and hydrogen from the battery limit at the right compositions, temperatures and pressures. The flow is controlled by a control loop and the mixture goes into a fixed bed reactor with several beds. There, nitrogen reacts with hydrogen to form ammonia. So, at the outlet we have a mixture of ammonia plus some unreacted nitrogen and hydrogen. We separate the ammonia by condensation in a heat exchanger. Then the mixture is sent to a KO drum. The liquid ammonia is separated and collected in the KO drum and is sent out of battery limits through a level control loop. The unreacted nitrogen and hydrogen, plus some remaining gaseous ammonia, are recycled by compressor K301 to the reactor. The compressor has a spill back line and also we have a purge in the plant to avoid concentrating impurities in the reaction loop. We have done a traditional PHA of the reaction section, and uploaded it to the Dynamic Risk Register. That's the result. The tableau contains cause, consequence, risk before safeguards, risk after safeguards, risk after recommendations and so on and so forth, what we are used to seeing in a conventional HAZOP. We have also included the diagrams and you can see that, for instance, in this P&ID, we have identified all pieces of equipment that are mentioned in the HAZOP, either as part of the cause, as part of the consequence, or as a safety barrier. We need to cross-link this P&ID with the hazard tableau, and this is done manually. The system creates a preliminary equipment list based on our input, and then we need to cross-link this list of equipment with the consequences, the causes and the safeguards. What can we do once we are here? We can of course edit this table. We can add new risk elements, we can modify basically every text in the table. We can change the risk assessment. Of course, behind that there is a risk matrix that we can also change. We could import new scenarios if we want. We can add or delete pieces of equipment that are cross-linked with the P&ID. So that's the addition section. Once we go into benchmark, something that we can do is show several types of statistics related to cause/consequence, risk or safeguards and recommendations. For instance, in this case we are showing the types of causes. These are equipment failure, human error and an external event. These statistics always aim to answer operational questions. In this case, for instance, if the major cause of risk in your plant is human error, then you may want to allocate a lot more resources to the training of operators for next year in your budget. On the other hand, if your risk stems from equipment failure, maybe you would want to invest more in inspection and maintenance. You can also obtain that as a table, of course, and then we can have a look. We have identified one cause. We can look always at the consequences associated with that cause. Or we can look at consequences. In this case, the consequences are people damage, environment damage or economic damage. And we can look at them also as a table. If you look into the details, you'll see the causes that lead to that consequence. So, everything operates as a structured database and you can slice it in many different directions. When we go into risk, you can see the risk profile of the reaction section. Here, we see the risk before safeguards. There are multiple options. I'm not going into a lot of detail of that. But you can, of course, view risk before safeguards, after safeguards and after recommendations. In this particular case, you'll see that after recommendations you are out of the unacceptable risks. You can look at the calculation of risk distribution by the sum of the risk values or number of scenarios. You can also change the scale selecting between the number of units or the percentage that entails. You can also see your risk profile on top of the risk matrix. So let me make this a bit smaller so that we can see the entire risk matrix. We can see the percentage or number of scenarios displayed in each cell of the matrix. And likewise for safeguards and recommendations, you can see the different types. Let me just switch to percentage. You can see that types of safeguards in this case, mechanical interlocks, pressure relief process alarms, admin procedures or process design itself. Again, that helps you to envision the actual safety basis of your plant. As always, you can view things as a table, and if you click on the detail part of our safety barrier, you'll see all the scenarios in which the safety barrier is mentioned. We can also look at things like optimization. Here, the chart shows the evolution of your risk as you implement, in this case, safeguards. Of course, it makes a lot more sense when we talk about recommendations, and that also aims to solve a typical question that we all see after every PHA. You come up with a list of, say, 200 recommendations, and the plant manager looks at you and says, "Okay, what do I do first? Because I don't have the resources to implement all of that at once." Then, this is the chart that answers this question. The blue bars show the risk reduction by each of the safeguards. And the background shows you the number of scenarios left in every color of the risk matrix, after you implement the recommendations. So, after the first recommendation has been implemented, you still have the red scenarios, but you have reduced the yellow. And you can see that after 1, 2, 3, 4, 5, 6 recommendations, you are already out of the red, so you don't have red scenarios anymore. After 7 recommendations have been implemented, all the risk reduction that you can achieve is basically completed and you cannot go any further. In all the charts that I have been showing you, you'll see that there is a comparison between the plant and a benchmark. You can get rid of this benchmark if you want, but it's always useful to have a basis of comparison. And you can have your own basis of comparison. Like, let's assume that you have created the management of change project. Then you can compare, you can select among all the projects that you will have in the database, and all the different versions of the PHAs that you have in the database. You can select this benchmark, and it will show you the different charts, using your basis of comparison. So, you can compare your plant with some changes, or you can compare your plant with an average of its peers or according to the average of similar plants at different sites of the same operator. So that's kind of a powerful feature. And finally, one last thing that we can do, if we go into the details section, is to envision all different parameters like cause, consequence, risk and safeguards and recommendations on top of the pand ID. In this case, the color shown is the maximum risk before safeguards of every scenario, whose cause is created by the equipment. For instance, we see that the battery limit is creating a high risk, a red risk and unacceptable risks somewhere else in the plant. The flow control loop likewise is generating a high risk somewhere else. But on the other hand, the reactor itself is not generating any risk because it's kind of a passive element. If we go into consequence, then we see the equipment that suffers the consequences, or the risk associated to these consequences. So, for instance, now the reactor is red because of course we have scenarios that can cause damage to the reactor. The nitrogen and hydrogen battery limit is shown in white because it's not suffering any risk. We can go to our safeguards recommendations. And then if we look at risk reduction provided by safeguards, there is a reduction scale on top of the chart. You'll see that the safeguards are color-coded, according to the risk reduction that they are providing. So that tells us that these are dark green, that's a low-level alarm relieving between 50 and 60% of the risk of the plant. That's probably preventing some gas breakthrough to another section, and reducing the potential for a catastrophic event and so on. So, that's a part of a powerful thing. But something more that you can do is you can disable elements. For instance, if I click on this safeguard, I can disable it so that the safeguard is no longer considered. You see that in this chart, the safeguard is shown as gray. And then if I go into the risk chart, we see that the risks have increased. For instance, this KO drum was shown in yellow before, now has become red. Why? Because it does not have this safeguard to protect it. So that again, it's a very operational feature because it tries to answer the question what happens if, for instance, I have to take this level out of service because it needs to be recalibrated? Or, what is the current status of the risk of my plan, given that this low-level alarm is out of service because the level gauge has failed? So, the bottom line is you can see that the design plays a key role in enabling the Dynamic Risk Register tool to be practically used to answer down-to-earth questions. The Dynamic Risk Register can upload digital PHAs, and pretty much every kind of PHA that are structured in a table, containing at least one column each for cause and consequence, as well as a minimum of one column for safeguards. That includes of course HAZOPs, what-ifs, FMEAs, and other types of PHAs. And that's pretty much it for this demonstration. Thank you again for taking the time to review it, and we will be happy to answer any additional questions that you may have.